PEEK, the strongest industrial FDM material, versus PPA-CF, the strongest consumer 3D printing filament I ever tested so far. And why are these test objects connected? Well, there is a reason for this worth $300, and I explain it in this video. Back at another material testing video. Recently I did a review of the PPA-CF and I was amazed with its strength, and I became curious how much stronger is the PEEK, which is the strongest industrial FDM material, because this can be printed on consumer 3D printers, and actually this was printed on BambuLab X1C carbon. I don't even have a printer for the PEEK filament, and here I use 3D printing services. Now this is not a sponsored video. Here I use the PCBWay services. And even if they are spending a fortune for sponsoring other channels, I completely understand they don't want to sponsor this video, because what if the PPA-CF will be stronger? And I don't want to have if in my video, so not only that this is not a sponsored video, but also for these test objects I paid for myself. And how is this possible? Because I'm earning approximately $10 per video. Very big thanks to my Patreon supporters, because they make these kind of videos possible. Without them, I think it will be very minimal activity on this channel. As since I paid for these test objects myself, I noticed one very interesting trick which saved me $300 at least. Let me show you the ordering process.
I started with uploading objects one by one, and for each test object the price was $71.54. So I decided to give it a try. I connected all test objects with this 1x1mm bridge, and I exported it as one STL file. And guess what? Price for all test objects was again $71.54. In the meantime, they asked me to confirm that I accept the risk that those thin bridges will break during the shipping. And also the price was slightly modified a little bit, and the final price was actually $178.74, which includes the shipping and the VAT fees.
Now this PPA-CF was printed a little bit differently compared to my review video. I increased the print temperature to 295 degrees Celsius, and I also reduced the part cooling to 50% from default settings to have better layer adhesion. And I can see that the printing is fine, so this overhang came out good. And since PPA-CF is basically a nylon, it is sensitive to moisture, and I dried the filament before the printing. And don't forget, don't try to place it in a microwave, even if it would be faster. Recently I saw a video where some crazy YouTuber placed his PPA-CF filament in the microwave, and yes, it catched flame, but everybody knows that carbon fibers act like conductive material, and it will catch flame in the microwave. I contacted that YouTuber, and he told me he unrolled the top 2 or 3 loops, and the rest of the filament was fine. Well, we learn a lot from these kind of videos. I mask his face just in case his wife is watching the video and to protect his personality. It is time to prepare them for the testing, and these connections are on the position where they will not affect the testing methods. And they're ready for the mechanical testing.
Only later I noticed that there is some warping on the PEEK test objects. Not big, but this is extremely hard for the printing. The PPA-CF objects are completely straight. Hook test, and the PPA-CF was approximately 1.8 times stronger than the PEEK. The layer adhesion test with vertically printed objects, and this is good layer adhesion, so those modified print settings are good. And let's see the PEEK, and this was quite disappointing. And now the tensile test. I started with PPA, but very quickly it exceeded the maximum of 200 kilograms. So I switched to the crane scale, but I don't really like this scale because it don't show the peak of one movement. So I have to analyze digitally, step by step, the footage. And it was slightly below 200 kilograms this time, but incredibly strong. And now the peak. This is strong, but I already tested several regular materials with this strength. Now actually I checked my summary table for my Patreon supporters, and I found 5 materials which are stronger than this value, but this is resin and this is CNC machine nylon, so only 3 FDM materials are stronger than this PEEK. And now the impact test.
PPA-CF, 0 position, PEEK.
And the first test where the PEEK was better than the PPA-CF. These are edge positions of the hammer, and here you can see the difference in height. This means PPA-CF is quite brittle material and PEEK is quite tough, And here you can see the calculated breaking energy in kilojoules per square meters. 3-point bending test, and here you can see when all loads are placed, but I'm placing them one by one, and I'm measuring the deformation after 1, 30 and 60 seconds. This is the deformation under 2.5 kilogram load, under 5 kilograms, and this is under 10 kilograms, and significantly more deformation on the peak test object. The deformation under these loads after 1, 30 and 60 seconds, smaller numbers are better, so PPA-CF is very stiff material here, but the peak it have more deformation, but look at this, on 10 kg it have a very minimal deformation during the time, so not bad results, but yes, compared to the PPA-CF, this is weaker. The creep tests the deformation under the constant load of 1.25 kilograms. Oh, much bigger deformation. 12.56. 15.85. I always start the testing with the creep test because it's the longest, so that's why I was surprised here. And I measured them every day, and let's see the last 5th day. This is the last day. Visually I cannot see any additional deformation, but let's measure them. 12.60. 16.02. Visually almost no deformation on them. This means even the peak can handle this load quite good and there is no creeping, and it was still in the elasticity zone. On this graph you can see directly measured values, the distance between two reference surfaces, and we can see more deformation on the peak, but with the creeping we need the difference between 2 days, and that's what we can see on this graph, and these are extremely low values. The peak has some minimal creeping, but this was also very small on day 1, but after this basically it stopped with the creeping. I have some negative values here, probably some inaccuracy in the measuring, but in both cases these are quite good materials if you need resistance to creeping. One more time our results without any additional comments, and I think I will not add this to line to that summary table for my Patreon supporters because these are printed with some different print settings, and I have the feeling that this peak is not really representative of its category. When I started this video I was quite sure that the peak will be stronger, only the question was how much weaker will be the PPA-CF. I mean, this is still industrial filament, but as you can see this is weaker. Actually this is not weak material, but compared to PPA-CF, yes, it is weaker, but that layer adhesion, I mean, I wouldn't print even figures or toys if the material have so weak layer adhesion. And I'm not sure if anybody have experience with peak filaments, is this weak layer adhesion normal or the PCBWay should tune their profiles. And now you can see why this couldn't be a sponsored video, unfortunately, but huge thanks to my Patreon supporters, because thanks to them I can create this kind of videos too. And for you a reminder, don't forget to subscribe and click the notification bell button too, because in most cases my videos are not recommended by YouTube algorithm. I'm not sure why, but this is just a friendly reminder, because basically my driving force is from Patreon donations, and this is independent from number of the views. And nowadays, after this kind of videos, I'm always getting questions, when will I test 2-lumen filament? And I'm in the discussion with the company, but first they want to print my test objects to test them themselves. I'm not too happy about this. Why are they hesitating? I mean, I would even buy the filament already, but the problem is that I couldn't find the company who will ship to Europe. If I would find it, I would already buy it, but sooner or later it will be tested. Only question is if the company will send it to me or I will buy it myself. Anyway, don't forget subscribe and notification bell button too, and you will get the notifications if that video will be finished. Thank you for watching and happy printing!